Okay, here we're looking at mass and weight. Notice that we've got a guy jumping off a cliff. Okay, he's got a parachute on. At the moment, he could have a velocity or speed equal to 0. Okay, but he could actually have an acceleration. It doesn't have to be 0. Okay, acceleration just tells you sometime in the future the velocity will be higher. So you could have acceleration of 1,000,000 if you wanted to. Okay, but usually we know that he's going to have acceleration of around about 10 ms to negative 2. Okay, so you can have acceleration independent of velocity. Even though he's stationary at the moment, he's just jumped straight across. In the vertical direction he has 0 velocity. He has an acceleration in the vertical direction. Now, because he has an acceleration, there must be a force providing that. Okay, and that force is going to be called the weight. Now, if he was up on above the moon, okay, so we've got the moon. Now, there's our moon. He's up above the moon, jumping off. Okay, on the moon, he will accelerate at a slower rate. In other words, his force is less. If he was so far away from our solar system that gravity was not around him, so he has to be almost an infinite distance away, then he will not fall towards anything. There is no weight. He will just stay where he is. So the important thing is, what is mass? Okay, we always would say, hey, go weigh something, and you'll put it onto some scales. Unfortunately, that is not particularly correct. Okay, we should really be talking about mass if the thing is measured in kgs, grams, or so on. Okay, so whenever we're talking about those units, we're talking about mass. Now, what is mass? It's not just how much stuff there is inside something. Okay, it's not how much stuff you chuck into a container. That is what we call the mole. Okay, and you do that in chem. Well, we do a little bit in physics. Mass is more to do with a resistance to the change in motion. If you had a tennis ball rolling along, okay, how do you change its motion? Well, you come in and you slap it side on, and it might change its path into a different direction. Okay, so what your slap actually is a force. So that force changes direction. Now, if we keep a constant force and we have 2 tennis balls, we have one full of lead, as you do, so this one's full of lead, and one that's full of air. Which one is the easiest to change direction? Keeping the same force, pushing on the side in the same amount of time, which one is the easiest to change direction? Hopefully you've said the one with air. Okay? It has a smaller mass, so it is easier to change its direction. Let's say this time we had a bicycle, some guy riding the bicycle, okay, and a truck. Now, both of these objects are going to be moving. Well, we want them to move, okay? So how do we get them to move? Well, in this case, we're going to get a strong man, okay? He's got his big muscles. Strong man to pull on each object, okay? Same guy. So first he's going to pull on the top here, first step, and then he's going to come down and pull on the truck. Now we're going to say that there is no friction. In other words, it is so easy to pull these things that the wheels will just turn just as easy on each one. There's no soft tyres or anything, everything's hard and can turn easily, and they're both on perfectly flat surfaces. Now, which one is the easiest one to start pulling? This guy can only pull with one force. Let's say it's 1,000 newtons. Oh, let's say 10,000 because he's really strong. Okay, not very possible, but let's just say it was. Then he can make this thing accelerate. Okay, which one will accelerate the fastest? Hopefully you've said the bicycle. If you said the truck, you need to think a bit more. This guy is going to accelerate the fastest. So this guy has less mass. Okay. So what is mass? Let's define it. Mass is the measure of an object's resistance to a change in motion. Now what's weight though? We've talked about mass, weight. Very similar, but they are different. Okay. Now, weight is the force. So force is measured in newtons due to being in a gravitational field. So force due to a mass being in a gravitational field. Okay, so force due to mass being in a gravitational field. Okay, or force due to on a mass due to the gravitational field. So we've got a mass here at the bottom. Okay, and he's going to have some weight on him because of this lines here, which is the gravitational field. So important thing here, gravity does not equal force. Okay, oh, should do it like this. Does not equal force. Okay, so do not write that. Gravity creates a force. Okay, so gravity creates a force. So they're not, it is not a force in its own right, it creates a force. Now depending on where you are, if you got Earth and you got the Moon, then the gravitational field around each one will be large if you're on Earth, pulling downwards, or small on the Moon. Okay, so which one has the greater force? Well, if you put the same mass, so let's say a 10 kg mass in the Earth's gravitational field and a 10 kg mass in the Moon's gravitational field, the one on Earth will feel a much larger weight force than the one on the Moon. How else can we describe weight? Well, if you were lying on the ground, okay, and some guy came along and stood on you, then the force you feel denting your stomach or having to hold up on your stomach is equal to the weight. Okay, so the force you feel pushing on you is the weight force. The reason why we don't notice it all the time is because when we're standing on ground, there is an upwards force called the reaction force that balances the weight force. So we don't go falling through the ground. Now, how do you calculate weight? Calculating weight, we use this formula. Weight equals mass times gravity. Okay, or gravity equals weight over mass, or mass equals weight over gravity. Now, for example, on Earth, gravity is generally going to be 10 meters per second or newtons per kg. Okay, so for every kg, we'll have 10 newtons of force pushing down. So let's say, for example, we look at your weight, might be about 55 kgs, okay, and we're going to multiply that by 10 newtons for every kg, then we get 550 newtons. So if you're lying on the ground and some guy of mass 55 kg stands on you, there will be a force pushing down on you of 550 newtons.